All right, guys, let's go over the rules for all of our different transformations. The first category that we have are translations, right, which are moving things left, right, up, and down. We're going to do everything just by 2 units for an example in this section. So if we have that we're going left 2 units, we're going to be subtracting 2 from x, and y would stay the same. So I'm going to move b 2 units to the left, calling it b prime. I'll move a 2 units to the left, calling it a prime, and then making our connection. On the next one, if we go 2 units to the right, then we are going to be adding 2 to our x and then doing nothing with the y. So 2 units to the right, I'll move a over into a prime, b over into b prime, and then make our connection. Then for going up and down, okay, going up and down is the y-axis that's being affected. So nothing's going to happen to your x. If we were going up 2 units, we would be adding 2 to y. Now in this case, it's going to go off the graph, so 1, 2. That would be a prime, and then b prime right here, making our connection. Last, we have going down 2 units, so nothing will happen to x, but we will subtract 2 from y. So down 2 units, giving us a prime, down 2 units, giving us b prime, and then making our connection. All right, so those are the rules for translations. Now let's talk about the different rules that we learned for reflections. Okay, so reflecting across the x-axis versus the y-axis versus reflecting across y equals x and y equals negative x. Now with reflections, you can use a counting technique. For example, okay, if A is 3 units away from the line of reflection, then that means that A prime is going to be 3 units away on the other side. So 1, 2, 3 units away, 1, 2, 3 units away on the other side, giving us A prime. B is 2 units away from the line of reflection, so B prime would be 2 units away on the other side. So the counting technique is an option, but we also do have a rule in case that we don't have a graph available to us. When you reflect across the x-axis, okay, your x stays the same, but your y changes signs, which we can see an example of if we look at A, right? A was originally at 2, 3. And if you look at where A prime is at, it's 2, negative 3, right? So the x stayed the same, but the y changed signs. Then if we reflect across the y-axis, we could still use the counting technique, right? A is 2 units away from the line of reflection, so A prime will be 2 units away on the other side. B is 2 units away, so B prime will be 2 units away on the other side. Okay, or we have the option of utilizing a rule. The rule for reflecting across the y-axis, okay, is that your x changes signs, your y stays the same. So either counting technique or apply the rule to the original coordinates. Okay, for reflecting across the line y equals x, your x and your y are just going to swap locations. So if A was originally at 2, 3, our A prime is going to be at 3, 2. So up or over 3, 1, 2, 3, up 2. There's your A prime. Your B is originally at negative 2, 2. So your B prime, you're going to swap locations, so 2, negative 2. So over 2, down 2. And then connect. If you were to think about folding your paper or creasing your paper on this green line, right, A and A prime would land on top of each other if you were to fold it over the line of reflection. Okay, now this rule, you're still swapping locations, but you are also swapping signs. So it's going to become negative y, negative x. So A is originally at 2, 3. So A prime is going to be at negative 3, negative 2. So negative 3, negative 2, giving you A prime. Okay, B is at negative 2, 2. Okay, when you swap locations and swap signs, oddly enough, it's going to remain negative 2, 2. right? Which makes sense because B is on the line of reflection. Therefore, B prime would be on the line of reflection as well. All right, now let's talk about our rules for rotations. Okay, if you want to utilize the idea of writing an X on your left hand, right, and a Y on your right hand, we can do the drive the bus technique, right? So if I'm driving a bus, and I don't know if my hands are going to fit in here, right, we're originally at X comma Y. Okay, if you turn the bus 90 degrees clockwise, right, these are going to swap locations. So it's going to become Y negative X. Okay, going 90 degrees counterclockwise is going to give you negative Y comma X. And then rotating 180 degrees around the origin is going to give you negative X comma negative Y. Okay, now let's just pick a point and apply it. Okay, so A is originally at 2 comma 3. If we apply the rule, A prime is going to be at 3 comma negative 2. So 1, 2, 3, 1, 2. Okay, B is originally at negative 2 comma 2. So B prime, if we swap, bring the Y to the front, X to the back, and change the signs, that's at 2 comma 2. So 2 comma 2. And then make your connection. Remember, 90 degrees clockwise is like turning your paper one time. So if we look at where our original AB is at, if we turn our paper exactly one time, okay, this is now at 2 comma 2, right? And 3 comma negative 2, which is exactly what we found when we applied the rule. Okay, 90 degrees counterclockwise, your A is originally at 2 comma 3. So your A prime will now be at, let's see, bring Y to the front, change the sign, X to the back. Then we'll do the same thing for B. B is originally at negative 2 comma 2. If you apply the rule, Y comes to the front, changes signs, X goes to the back. So B is negative 2, or B prime. A prime is at negative 3 comma 2. And again, 90 degrees counterclockwise would be like turning your paper one time to the left, right? So if you were to rotate your paper one time to the left, notice we're at negative 3 comma 2 and negative 2, right? So that makes sense. Last but not least, okay, we'll take our original coordinates, and you are just negating the X and negating the Y. So negative 2, negative 3. And then for B, B is originally at negative 2 comma 2. B prime, if we apply the rule, is going to be positive 2, negative 2. A 180 rotation would be like rotating your paper twice, either twice to the left or twice to the right. All right. Next, we have dilation, stretches, and shrinks. This conversation ties in with our similarity unit because when you dilate a figure, it creates a similar figure. Now, dilating from the origin by a scale factor of 1/2, that means you're going to take your X, multiply it by the scale factor, and take your Y and multiply it by the scale factor. So if A is originally at 2 comma 3, then your A prime, 2 times 1/2 is 1. 3 times 1/2 is 3/2 or 1.5. So 1 comma 1.5. Then for B, B is originally at negative 2 comma 2. If we multiply those by the scale factor, we're going to get negative 1 comma 1. Right? And not only is it half the size, but it's halfway closer to the center of dilation, which they said was the origin. So halfway closer to the center of dilation, half the size. Now you need to be careful with this next piece because this is just a horizontal shrink or stretch, and this is just a vertical shrink or stretch. Now horizontal, if you think about horizontal, it's the x-axis that's being affected. If you think about vertical, it is the y-axis that is being affected. So for the rule on this one, it is just your x that's being multiplied by the scale factor and not your y. Okay, for vertical, your x stays the same, your y is impacted by the scale factor. So a is originally at 2, 3, which means your a prime is going to be at 1, 3. So 1, 3. Here's your a prime. B is originally at -2, 2. And your b prime is going to be at, if we multiply just the x by 1/2, -1, 2. So notice, okay, it only shrunk horizontally, right? It squeezed in horizontally. There was no vertical change. On this one, if we're originally at 2, 3, and we multiply just your y by 1/2, it's going to be 2, 3/2 or 1.5, whether you want to represent it as a decimal or fraction. So over 2, up 1.5. And then your b is originally at -2, 2, which means your b prime is going to be at -2, 1. -2, 1. Okay, notice this shrunk closer to the center of stretch, which is the origin, okay, but it did not shrink horizontally, just vertically. All right, an enlargement is when your scale factor is greater than 1, so scale factor greater than 1. A reduction is when your scale factor is less than 1, but greater than 0. I'm going to go ahead and end the video here, and the next video will wrap up the following side.